and welcome back to another episode of the Mathlete Academy. Today we'll be going over Chapter 13, Trigonometry, in your guys' textbooks. But first, what is trigonometry? Trigonometry is basically the study of triangles, particularly those with right angle triangles, in relation to how we can find the angles and sides lengths of a particular triangle. Let's just say here we have this right angle triangle. As you know from Pythagoras, the longest side here is called the hypotenuse. Now, let's just choose a certain reference angle. Let's say here, and we'll call this angle theta. Now, what do we call the side? What do we call this side of the triangle? We call it the opposite. The opposite side, because, as you can see here, it's opposite to the reference angle. And we call this side, the remaining side, the adjacent side, because it is adjacent to the angle. Now, these sides, the opposite and adjacent, can change. So if we put the angle here, then this side would become the adjacent, and this side would become the opposite, as you can see here. The long side, opposite to right angle, will always remain the hypotenuse, no matter what. So, using these, we can find a few trigonometric ratios. These are the three basic ones that you'll need to know. So, the sine of angle theta is equivalent to the length of the opposite side over the length of the hypotenuse. So, let's just say we have back to our triangle right here. Let me just erase a few things. So, if we want to find this angle right here, so let's call this angle alpha, and we have the lengths of the opposite and the hypotenuse, we can use the sine trigonometric function in order to find angle alpha. Plug this in for your angle, so we got sine alpha equals the length of the hypotenuse, length of the opposite, sorry, over the length of the hypotenuse. And then all we need to do to find alpha is simply use the inverse trig function. So sine -1 equals opposite of this will give us our angle. So the inverse trig functions are used in order to find these certain angles, because as you see here, if we divide both sides by sine, or multiply them by sine over 1, because sine over 1 is just equal to the inverse of sine. Right? So if we divide sine from both sides, we get the inverse of sine over here with the opposite over hypotenuse. This also applies to the cosine function, or cos, which is adjacent over hypotenuse. So it would be this side here, adjacent. To find this angle, all we do is take the adjacent side over the hypotenuse and plug it into the cos function. And same for the tan function, which is opposite over adjacent. So we take the length of the opposite side and divide it by the length of the adjacent side to get this angle. These ratios can be used to find a number of lengths and angles, as we shown earlier, and the two angles opposite to the right angle are complementary. So these two angles will always add up to 90 degrees. Because a triangle, remember a triangle, all the angles inside internally sum up to 180 degrees. And since this is a right angle triangle, we already have an established right angle here. Therefore, these two angles right here must add up to 90 degrees. Therefore, we can use a few things when relating the sine and cosine function, because these deal with these lengths. So obviously here, cosine minus theta, cosine 90, minus theta equals sine theta, and sine 90 minus theta equals cosine theta. because these always have to be balanced values. For example, if we have 20 degrees and 70 degrees, this one's 90, in this triangle, and we say that this theta is the reference angle, therefore we'd be saying that the sine of theta is like opposite over hypotenuse, and then 90 minus theta gives 70, right? So cosine is just this. So we take, obviously we have 20 degrees as our theta here, so we do 90 minus 20 gives us 70, and this is equal to cosine theta, because cosine theta equals hypotenuse. This is just all an angle, right? You can probably cut some of this out, I'm gonna be honest. So we can prove it. We can do some stuff using this triangle right here. So sine theta, remember we're establishing this angle here, so this is the hypotenuse, this is the opposite, sorry, this is the hypotenuse, and this is the adjacent. So therefore sine theta equals 10 over 26. Cosine theta equals 24 over 26. And tan theta equals 10 over 24. This is how you'd be able to find, and then from here, obviously if you want to find the theta values, you take the inverse sine, inverse cosine, and inverse tangent on each side, and you can use this in a calculator. Now these are some basic trigonometric ratios that you probably want to know. So the sine of 30 degrees is equal to 1/2. Then the sine of 45 degrees is equal to 1/2 of root 2. Sine of 60 is equal to 3 over root 2. And then cos, with the cosine function, it's 3 over 2, 1 div root 2, 1 over 2. Then tangent, we have 1 over root 3, 1 root 3. Now, in order to see how some of these would work, let's just draw Alright, so in order to prove another one, let's try and prove sine of 60 and cosine of 60. So let's just say we have a equilateral triangle here where all the sides are equal to 2. So 2, 2, 2. Now let's cut this one in half. Now, since there was one equilateral triangle, all of these were equal at 60 degrees. But now that it's been cut in half, these two angles right here have been split into two sets of 30 degrees, while these still remain as 60 degrees. So, and then this one has become, these two are 90-degree angles. So therefore, the side length here for this little individual section is 1. And in order to find this length right here, we just use the Pythagorean theorem. So obviously we have our long side right here because it's opposite to the right angle. So then we take c squared equals a squared plus b squared. So a squared, which will attribute this side to a and this side to b. So we'll say that a squared equals c squared minus b squared, which is 4, because 2 squared is 4, minus 1, which is 3, and therefore a is just equal to the square root of 3. So therefore, we have constructed this little triangle. Let's just automatic shapes. We've just constructed this little triangle that has side lengths 1, 2, and the root of 3. So this is root 3, as we've proven earlier. This is 2, this is 1, and then we've got our side 60 degrees, and we've got 30 degrees here. So we have to remember our trigonometric ratios. So let's just try and prove all of them actually over here. So our reference angle here is 60 degrees. So our sine equals to opposite over hypotenuse. So the sine of 60 equals 3, because this is opposite, over 2. So root 3 over 2. Then we'll have cosine, which is adjacent over hypotenuse, which is 1 over 2. So it's just 1 over 2. And then finally, our tangent is opposite over adjacent, which is equal to, so we got our opposite is root 3 over our adjacent, which is 1. So our tangent value is just equal to the root of 3. And now, as you can see, these are the same as our trigonometric ratios established right here. These are all the simplest forms of these trig ratios, and you'll be able to see them in your work, because these will be just the simplest forms right here. Now, when you're trying to solve these trig problems, you need to know, obviously, your inverse sine functions, as we were discussing earlier. So the sine negative of 1x is the inverse sine of x. So sine negative 1 of opposite over hypotenuse gives you your angle theta. Does not necessarily mean 1 over x, but it does mean that it's just the inverse sine. So it'll give you back your theta value. As you can see here, these are the different rules. So if x is greater than 0, then tan negative 1 is the angle whose tangent is x. If 0 is greater than x is greater than 1, then sine negative 1 is x is the angle whose sine is to x. If 0 is greater than x is greater than 1, then sine negative 1 x is angle whose cosine to x. Now, if you're wondering why the x value here is constricted between 0 and 1, it's because our sine and cosine values can only go from 0 to 1. They can't go above and they can't go below. Our tangent value can go from 0 to infinite at 90 degrees. So we'll be using our trig functions in order to solve these problems, and I'll just help you along. So we have this, which obviously we've got our opposite and our hypotenuse, so therefore it's going to be a sine. So the sine of theta equals 8 over 12. Therefore theta will equal sine negative 1 8 over 12. And you can figure this out on your own calculator as well. It's pretty easy in order to do, but and then here we've got an adjacent and a hypotenuse to this angle. So cosine of theta equals 9 over 16. Therefore equals this. Hopefully you guys are following along. Then here we've actually got a tangent because because we have our opposite and we've got an adjacent. So the tan of this angle, theta, we're just going to assume it's theta, but here it's technically alpha, but yeah. The tan of this angle equals 12 over 5. So our theta value is the inverse tan of this value. Now, we can pull out our calculator in order to answer these questions. So, we'll first do the inverse tan one. So, and you can really use any calculator here, but here you just gotta make sure we are calculating in degrees. So make sure that you're in degrees, not radians. That's just a function on your calculator. Alright, so by using I got my little calculator out right here. And so what I'm going to do is I'm just going to plug this in to my calculator. So the sine of the inverse sine of 8 over 12, which obviously you just need to use the inverse sine here when calculating these. So the inverse sine of 8 over 12 in degrees specifically. Remember, you've got to specify it's in degrees. So sine of 8 over 12 is approximately 41 degrees. 41.8 degrees. So over here, the cosine value, the inverse cosine of 9 over 16 of 9 over 16 in degrees is 9 to 6 in degrees. It's approximately 55.77, which just rounds to 55.8. Finally, the tangent of 12 over 5, the inverse tangent calculator. So we're just going to plug in tan minus 1 on our calculator right there. So tan minus 1 of 12 to 5 is approximately 67.3 degrees. And this is how you're able to find the value of these three trigonometric ratios. But what if, for instance, you wanted to find a difference? What if you wanted to find the side length? So let's just say x. We'll say an angle is given at 45 degrees, and you have the hypotenuse length. Let's just say it's the hypotenuse length is 10. What are we going to do here? So we have an opposite side and we have our hypotenuse. So we're going to be able to use the sine function. So sine of 45 degrees is equal to x, which is our opposite, over 10, because remember, this is just opposite over hypotenuse. So in order to find the x value, we just take 10 to the other side. So we do 10 times sine 45, obviously in degrees. And then obviously you can run this through your calculator. Remember that sine 45 is one of our handy trig ratios right here. So sine 45 is equal to 1 over root 2. So our answer here is going to be 10 times 1 over root 2, which is just 10 over root 2. And that is our answer. Obviously you can simplify this down if we had a calculator. But this is the side length of x, 10 over root 2. And in order to help us verify, obviously a 45 degree, this means that this side will also be 45 degrees. Therefore, our adjacent will be 10 over root 2. So we can just use Pythag to verify that this is correct. So 10 over root 2 squared plus 10 over root 2 squared. This equals 100 over 2 plus 100 over 2, which is 50 plus 50, which equals 100. And then obviously our hypotenuse is just the square root of this side, which is 10, which is what we found here. So therefore this value that we've just verified that this is the correct value. Alright, just some more things that you might need to know about trig. So we've got angle of elevation and angle of depression. These are just the angles going up and the angles going down, and we can use trigonometry in order to help us solve these problems. So let's just draw a diagram for this this problem. A rope 4 meters long is attached to a vertical pole. The rope held taut is pegged into the ground at 2 meters from the base of the pole. So a rope 4 meters long is the rope held taut is pegged into the ground 2 meters from the base of the pole. Alright, so that means that we have a rope 4 meters long. So we have an angle of depression right here. So we have the height of our pole here with a rope held taut. From the base of the pole means that it's pegged 2 meters away, and obviously we have our length here of 4 meters. And this right here is the angle of depression, because this is the iso. We've got our angle of elevation right here. Find the angle that the rope makes with the ground. So this would be our angle of elevation right here. So obviously in order to find this, we have the adjacent and we have the hypotenuse, as you can see with this right angle triangle. Therefore we're just going to use the cosine function. So the cosine of this angle equals 2 over 4. And here it equals 1 over 2. Now remember, this is one of our handy trig ratios right here. So the cosine of theta, when it equals 1 over 2, it means that theta is 60 degrees. Therefore, we can just say that theta here is equal to 60 degrees without having to do any advanced math problem solving. Find the angle that the rope makes with the pole. Therefore, obviously you can go about this in two ways. Obviously we know that triangles add to 180 degrees, and this is 90 and 60, so therefore this must be 30. We can also solve this using trig. So we'd have this angle right here. Obviously this would be the opposite, this would be the hypotenuse. So therefore we have the sine of this angle, which pretend we don't know it, equals opposite over hypotenuse. So which equals 1/2. And remember that when sine of theta equals 1/2, that means theta equals to 30 degrees. But we also have another way of proving this, and this isn't directly related to trigonometry. But if you remember, that since these lines here are parallel, therefore that these angles right here have to be equal, considering this line, and these two lines of this line of observation, have to be parallel. So that's not really trigonometry, right? You can probably cut that a bit out, actually. And then finally, over here, we have true bearings. So a true bearing is just just the direction that north is in, and angles rotate counterclockwise. So, sorry, not counter. So true bearing is just the direction that north is in, and angles will just rotate clockwise around it. So we have this angle right here. This would just be, let's just say this angle right here is about 300 degrees. Therefore, this direction is 300 degrees true bearing north. And when you're writing true bearings, you write them in degrees T, like this. Just a little signification. And when you write your true bearings, you always do them to 3 digits. So if the true bearing is less than 100 degrees, you would just put a 0 in front of it. Like here, let's just say that this is 40T. This is probably not to scale. It would be written like this. So 40 degrees is just 0.4T. So our true bearings with this, right here, obviously we go around clockwise like this. So 30 degrees right here. So A would just be at true bearings 030T. B, being opposite to this, is just 30 degrees plus 180, because this is a straight line. So therefore 180 plus 30 is just 210. So B is at true bearing 210 degrees T. And finally C would just be 360, a full rotation, minus 20. So C is at 340 degrees T. And then we've got one final question right here. Anthony walked 100 meters. And this just combines a bit of trig with true bearings. So let's just say point A. So obviously we've got our true bearing north right here. Once it walks on a bearing of 240 from point A to point B. So 140 degrees. Let's draw a diagram to help us visualize this. This is point A, and this is point B. Right, and now using this, we can help find the distances between these. So how far east is point B from point A? Obviously, we've got north, south, east, west, right here. So east would be this direction, right here. And so obviously we've got 140T, and therefore this has to be 40 degrees, because you're adding on up a straight line. And to find this length, it would just be, and then obviously we've got our hypotenuse length right here, and we have our angle of 9 degrees right here. So in order to find this length, we've already got an angle, we've already got the hypotenuse length. We can use the sine function, because this is just going to be the opposite. So the sine of 40 degrees, equals x length right here, over 490. Therefore we can just take 490 the other side, times sine 40 degrees. And I'll just solve this on my calculator real quick. So 490 multiplied by sine 40 degrees. Just make sure, remember that you're always doing this in degrees, not radians. which is another function on the calculator, this is approximately equal to 315 meters. We'll round to three significant figures. So it's 315 meters east of point A. Now, obviously, if we're trying to find how far south it is, we just need to find this value, y. So, the sine, this time we'd be using cosine, not sine, because obviously we're trying to find the adjacent length right here. So the cosine of 40 equals x over 490. Well, not x, sorry, y over 490. Y equals 490 times cosine of 40 degrees. Which in this case is equal to 375 meters south, if we're using three significant figures. Obviously, for these types of equations, you want to make sure that you're using just sine, and inverse sine is only saved for the ones where you're trying to find the angle, right? So obviously sine angle equals, and you know these two lengths, just say 4 and 6. That's when you use inverse sine, so in the inverse sine of this. But if we're just trying to find, if we know this angle, and we're just trying to find, so let's just say it's 40, and we're trying to find one of these two values right here, we just use the regular sine function. Just this is an important distinction to know, and it might help you in terms of figuring out these trigonometry problems. Alright, that's just going to be it from me today, guys. Thank you for your time. Ask us in the comments if you have any questions.